In this section, we will talk about complex numbers. So here's what we know. For any number a squared, and when you square a number, it's always going to be greater than or equal to 0. For example, if you square 2, 2 squared is 4. If you square negative 2, you still get a positive 4 because a negative times a negative is equal to a positive. So the question is, when we square a number, can we ever get a negative 1? Well, we can't, because when you square anything, even if it's a negative number, we will get a positive number in the real number system. So the imaginary unit, denoted by I, is a number whose square equals to negative 1. Since this doesn't happen in the real number system, in the imaginary system, here's what we say. We say that I is equal to the square root of negative 1. The imaginary unit is a unit whose square is negative 1. And so if you square I, then this equals to the square root of negative 1 squared, which equals to negative 1. So while I is an imaginary number, square root of negative 1, I squared is a real number, which is negative 1. Complex numbers are numbers in the form a plus bi, where a and b are real numbers. The real number a is called the real part, and the real number b is called the imaginary part. And it's always written in this form of a plus bi, where the real part comes first and the imaginary part comes second. And this is called the standard form of any complex number. When we square root a negative, we can split this up into the real part times the square root of negative 1. In essence, we're pulling out the square root of negative 1, which turns into an I. So, for example, if we take the square root of negative 9, this will equal to the square root of 9 times the square root of negative 1. The square root of 9 is 3, since 3 times 3 is 9. Therefore, this result is equal to 3i. Square root of negative 25, this is equal to square root of 25 times the square root of negative 1. Square root of 25 is 5, since 5 times 5 is 25, so this results in 5i. Now let's combine that. Take the square root of negative 9 times the square root of negative 25. Now here's a common mistake students make. The instinct is to multiply this and write square root of negative 9 times negative 25. That's 225, which is actually incorrect. And the reason is because we have a square root of a negative number, we have to simplify this negative square root first before we can multiply. So based on this example here, square root of negative 9, this is equal to 3i. And square root of negative 25, that is equal to 5i. So if we multiply 3i times 5i, multiply 3 times 5, which is 15, and I times I, which is I squared. Now this part is really important. Every time you see an I squared, you replace that with a negative 1. So 15i squared, this equals to 15 times negative 1, which in fact is equal to negative 15. The sum of complex numbers. We would add complex numbers just like we would add any expression where we add the real part, the a plus c, and then we add the imaginary part, treating the I just like a variable. Same thing with subtraction. The negative distributes, so this becomes a negative c and a negative di, and then we combine our like terms. So for example, we want to subtract 4 plus 7i minus 9 minus 18i. First, we will rewrite this. The 4 plus 7i stays as is because the parentheses has a positive coefficient, but the negative will distribute to the 9 and to the negative 18i, turning this into a negative 9. Negative times a negative, this becomes a positive 18i. Now let's combine our like terms. 4 minus 9, that's negative 5. 7i plus 18i, this equals to 25i, which is our answer. Multiplication of complex numbers works exactly like multiplication of two real expressions, with one difference, which we will talk about at the end. But let's first multiply this. So you can multiply it any way you want to. You can just FOIL it, but for the purposes of this problem, I'm going to split it up like this. I'm going to make a 4 by 4 square. You don't have to do it this way, but I'm showing it for the purposes of simplicity. So we have 3 plus 4i on one side, and then we have 2 minus 6i on the other side. Okay, so let's multiply and put each result in its corresponding square. So 3 times 2 is 6. 3 times negative 6i, that's a negative 18i. 4i times 2, that's a positive 8i. And 4i times negative 6, so you have a positive times a negative, that's a negative. 4 times 6 is 24, and I times I is I squared. This gives you a negative 24i squared. If we were to FOIL it, you would get the exact same result. 3 times 2 is 6. We got the 6. 3 times negative 6i, that's a negative 18i. We got the negative 18i. We have 4i times 2, that's a positive 8i. And then we have a 4i times a negative 6i, that is a negative 24i squared. Then we combine our like terms. But before we can do that, we have to remember that every time you see an I squared, this replaces with a negative 1. So I'm going to rewrite this as 6 minus 18i plus 8i. But now the I squared gets replaced with a negative 1. And a negative times a negative is a positive. So this will give you 6, negative 18 and positive 8. Those are like terms. If you combine those, we get a negative 10i. Negative 24 times negative 1 is a positive 24. If we add 6 plus 24, this will give you 30 minus 10i. So we talked about adding and subtracting, we talked about multiplication. Now let's talk about division. So we want to divide 6 by 3 minus I. So 6 divided by 3 minus I. Here's what we know. In order to divide by a complex number, we have to multiply both the numerator and the denominator by its conjugate. So what does this word mean, the word conjugate? Let's say we have a plus bi, then the conjugate will be a minus bi, and vice versa. If we have a minus bi, the conjugate will be a plus bi. So it's the same numbers, except the sign changes. So let's take 6 divided by 3 minus I. To divide a complex number, we're going to multiply both the numerator and denominator by the conjugate of the denominator. So if we have 3 minus I, its conjugate is going to be 3 plus I. The terms stay the same, the 3 and the I, but the sign changes from a negative to a positive. Same thing on the numerator. That becomes 3 plus I. Okay, so now let's go through and multiply the numerator, multiply the denominator. So the numerator should be pretty straightforward. 6 times 3 is 18, and 6 times I is going to be 6i. The denominator, you can do this in any way you want to. You can FOIL it, you can make a box, it's up to you. So I'm just going to make a box to show you guys what's going on. So we have 3 minus I, and then we have 3 plus I. Okay, so one expression goes on one side, the other expression goes on the other side. 3 times 3 is 9. 3 times I is 3i. Negative I times 3 is negative 3i. And negative I times I, that's a negative I squared. So these are my 4 terms, which I will copy down here. I have a 9. I have a plus 3i. I have a minus 3i. And then I have a minus I squared. Now, this didn't happen by accident, that in the middle we have a positive 3i and a negative 3i. We forced that to happen because we kept the same terms, but the sign changed. So you get one positive and one negative. And that's going to force the imaginary part to add to 0 or cancel out. So if we have a 3i and a negative 3i, that adds to 0. Okay, so now here's what we have. We have 18 plus 6i on the numerator. We have a 9. And remember, I squared, that's actually equal to negative 1. So we have minus negative 1. We got the minus sign, and I squared is negative 1. The two negatives we know are going to add to a positive. Negative times a negative is a positive, so that becomes a plus sign. And if we simplify this, we have 18 plus 6i divided by 9 plus 1, which is 10. Now lastly, remember our standard form is a plus bi, which means the real part and the imaginary part have to be written separately. So we are going to write this as 18 over 10 plus 6 over 10i. So now we have the a plus bi. To reduce this, we would divide these by 2. So 18 divided by 2 is 9. 10 divided by 2 is 5. 6 over 10, 6 divided by 2 is 3, 10 divided by 2 is 5. So our answer is going to be 9 over 5 plus 3 over 5i. Here are some practice problems which I would like you to think about, and we will do these in class.